Hey, what's up, folks? Welcome back to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit. Joining me every week, it's brother Pedro.
Good morning, everybody. Pedro, Creative Tech here, Adafruit, and every week we're here to share the 3D printed projects featuring electronics from Adafruit.
Yes, it's all right. This is the show where we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. Welcome to this live stream. It's episode 494, and it is August 6th, 2025. Welcome, everybody, to the show. We're streaming on all the different networks. We're also going to give special shout-outs and attention to the Adafruit Discord. The link to that is at the top banner here. Let me bring it up. discord.gg/Adafruit. That's the URL if you are not a part of the Discord yet. And we're hanging out in the live broadcast chat channel, where we will stop in every so often to check in with the chat. Questions, comments, GIFs, GIFs, memes, all that is good. We have a special coupon code that we'll share in just a moment. And what other housekeeping stuff do we have? We'll talk about CircuitPython Day. We got a new project. We have lots of prototypes, doing so many prototypes. And I think a time lapse. And no community makes this week, but other than the time lapse. Yeah, so let me give some shout outs to folks that are hanging out in the Discord. We got squid.jpg, we got Duester, and Paul Cutler. Good morning to you folks. Okay, and then if anyone else on any of the other channels wants to say hello, we can bring you in from Facebook, LinkedIn, YouTube, Twitch, and X. Okay, let's start it off with Adafruit.com/free. We still have freebies going on, starting off with orders of $99 or more. You will get a free PCB coaster with a golden Adafruit logo. If your order is $149 or more, you'll get that PCB coaster plus an Adafruit KB2040. It's a lovely microcontroller featuring the RP2040 chip and lots of GPIO pins. And at the top tier at $199 or more, you'll get the KB2040, the PCB coaster plus free ground UPS shipping for continental use only. So check out Adafruit.com/free. Again, these get automatically added to your cart. And while you're at the checkout, why not use our 10% off coupon code? Good for the next 24 hours. USBC Fixer is the coupon code. All one word, all undercase. Undercase? Yeah. Lowercase. That's the word. USBC Fixer is the coupon. And it's good for the next 24 hours, like I said. All right. Could definitely use some more coffee.
Oh, no, I thought you were making it.
I was not. I ran out of time. I gotta get all the demos and stuff ready. Anyway, Pedro, you've got this week's project. What is this week's project?
This week is the finalized version of the... Hold on, let me get that. Yep. This week is the finalized version of the USB-C fixer. This is the case design that we sent in to JLC PCB to get 3D printed in SLA. This was the one from last week. You know how it is. Once you start using things, you start noticing features that need to be added. So for this one, one of the features that I added was more tougher snap fit parts. And then another thing is I noticed when I was plugging it in and out, the USB plug started to bend a little bit. So I added a retainer. So we have geometry to that. Oh, man. Let me go over here. You can...
Sure. I can switch you up here.
Better. See that better if I focus.
There we go.
The retainer piece right there on the top, just to make sure that the USB plug does not bend. And then we added some filleted text so you know which side is which. So for assembling the case, that'll be a lot more easier while still having access to this socket. And then even with the retention added, you still have enough clearance when you plug that into any of your devices. So the other thing I had to look out for to make sure that you're not blocking, fully seating the USB-C into your devices. And then, of course, for doing the video, I had to look for actual devices that this would work with, because this is very particular in terms of the way that it works. It has to be a device that does not have a resistor on there. Luckily, I did find some of those things that did not have the resistor. Jump back over to my screen here. Our knockoff MagSafe battery.
What a great example. A knockoff MagSafe battery.
It's so knockoff. The magnet on here is so weak. It like barely holds onto the phone. So when I plug it in, it will not charge. But with the resistor, it will.
Gosh.
Angle that so you can see the USB light up.
There you go. All right.
Oh, I was trying to get this side so you can see the little
Okay.
glowy. Have a little cutaway so the light will go through, and then you can see that it starts charging. So perfect example for that. Something that would not work with just the cable by itself for whatever reason. Of course, it's a knockoff, so they didn't include the 5.1 K resistor.
Yeah.
Besides it, so super handy for that, and it's nice and slim. One of the other UX elements that we added to it too was just completely smoothing out the little snap fit portion that grabs onto the nubs, so that's all nice and smooth. So when you're removing this, it's not gonna poke your thumb.
Yeah. So this is the SLA print, or is it FDM?
No, this is FDM. I printed this at 0.12 layer height, so it's super fine. That was the quality we used to verify what we're sending into JLC. It's pretty dang close. Like you can tell the difference. I used a different filament that we were testing on it, and it looked like an SLA print. So that's what that looks like. Of course, the socket down here, so you can plug in any other cable. And then here's what the bare PCB looks like. And you can see here, this is why we had to make a case, because without it, it would be just a naked dangling PCB with circuitry hanging around. You don't want that, especially if you're charging stuff. You don't want that to get shorted out. So, of course, nice little protective case. This will be in the shop, or you can, of course, just 3D print your own. Super simple assembly. I should have brought my spudger
Spudger. Okay.
Yeah, but
you don't. Yeah, you kind of want it to stay closed. You don't need to take it apart. So
the other consideration was making sure we were able to have this snap fit with variations between the perforations on the PCB board. So that was the other thing. So I did an average of what my backup PCB one and this one is, to make sure that it still snapped on without being loose. And nice little snap fit there. And then we have, of course, like we said before, the text. I did go ahead and just delete the one that had the dual color on there. We have the protrusion on this one because, of course, we can't do the dual color from JLC.
Right.
So I went with this route. So unfortunately, it does need support material because of the way that it prints with the protrusion. I didn't want to go the route of punching it inwards, specifically because of the way that the little light shines through on that one. It would have definitely messed with the way that it diffuses, and I didn't want to increase the thickness of the case just to have that in there. So I just made the text protrude out. And because of that, you can't lay it flat on the bed, so it does print vertically. And I think that's how they printed at JLC. So
yeah, I think they printed at like weird angles.
Yeah,
with like the most support.
Exactly. So that is how we're gonna have to orient it on your bed if you are printing this at home. But because this is such a teeny tiny little print, the cost of these shouldn't be too much. And of course, we give away the Fusion file, so you can go in there and just suppress the text extrusion, and then just have it punch in if you want to print without the supports on there, so you could lay it flat on your bed.
Yeah.
But I didn't want to, for media management, I didn't want to have two different versions of the file. So
Sure.
Yeah. Just make one.
Yeah.
And, it looks really good.
Yeah, it does.
Hopefully one day they'll have dual extrusion, so I won't have to do the protrusion on that. And then, yeah, that's pretty much it. Super simple. I think the other thing that we used too was the band case for that.
Ray-Ban case.
The Ray-Ban,
right?
yeah.
Your Meta glasses.
And as you can see here, it does charge. And I was like, well, why does it work on mine but not Brandy's, my wife?
Yeah.
And it's like, oh, they made different hardware versions of it. So it's like, okay, so
oh, really?
you are getting it's so particular, which is so funny because hers are like a newer one than the case that I have. So it's one of those things where it's like, oh man, there's always hardware revisions that happen without people knowing. So handy to have around in case you do get one of those oddball ones where it is an older version or where they, revert to not using those resistors or for whatever reason. And then the other thing that I found out too was the outlet that I was using, it is like a UK plug, like it has a USA converter, and that's where it worked or where it refused to charge, where I had to use the USB-C fixer. So it also depends on the outlet you're using.
Yeah. Yep, it does.
How funny.
Cool.
In the cable.
All right, let's take a look at the
All
real quick at the guide
versions.
so you can show the product and all that stuff. It's in stock, which is nice.
Yay. All right, so here is the guide for that. Again, it is just a placeholder for the 3D files and just a little rundown of what this is used for and the examples. It is in stock. Yeah, woohoo. And then some of the cables that you can use with it as well. Like the swivel one is really cool. You can swivel that around so you don't have to unplug things and replug them to adjust for like if you're coiling your wire. Yep. See, like we were saying before, in the 3D printing page, here is how you're going to orient your file. I do have I should upload the 3MF file, so it's already set up with the support materials all ready to go. But again, you can go into the Fusion file and download your preferred format. Here's what that looks like with the lovely PCB modeled by you, Noah.
Yep.
So in there, and if you want to use this on a different project, you can make a different case or whatnot. And here's our crazy exploded view of what that looks like. With all the crazy pins going everywhere. And then here's the little USB LED light. You can see it does a little cutaway so that the fusion can take place. And the text is editable, so they are just the text tool inside of Fusion, so you can go in there and edit that if you need something else. But I thought that would be quick, just in and out for the socket and the plug.
Yeah.
Didn't really an assembly page, but here it is. It's so simple. You just place it, make sure that you align the text. The out is the plug and the in is the socket. And the only real thing you got to look out for is the top and the bottom. The bottom shell is going to be where the little smaller nubs that are grabbed onto. That's how you'll lay the PCB, and it should snap in. Hopefully the tolerances are good, depending on how the PCB perforations are cut or shaved away at. So there is spacing for that. And then, as usual for the snap fit stuff, you'll join one side of the little grabber into the nub, and then using a little bit of force, snap on the opposite side to join it together. And that is it.
Very nice.
If you have any of those devices won't charge, you don't know why, this little device can help bring back the charging for that. Super simple.
Yep.
So it'll cost.
Request from Lamore and PT.
Yes.
So we had to do it. Very nice. Yeah, I'm gonna wait to when we get those in shop. I'll get my hands on one and sure I have a device somewhere on here that that could utilize that.
Yeah. I should have put on here that I can get any of the iPads in any of the configurations with the like outlet or the cables for it to work. And,
yeah, it's only for devices that skimped on those resistors. So the iPad didn't. And knock off batteries, I guess. Yeah.
Yeah. I mean,
on those.
yeah. And somebody asked the question, if it does work, can you still use it? No. On the iPad, actually,
it won't
like a
work.
cable that will work. If you plug this in, it won't work. It'll stop it from working.
It's doubling the resistance.
Yeah. Like, no.
Too many resistors. Yeah. I think PT and Lamore got it, designed it, manufactured it so that they can get their baby monitor to start charging again or something.
Yeah, I'm guessing it's for things that are like universal, like overseas and like stuff both in the UK and over here. Like I've gotten devices where it includes like the 2-prong plug for UK with a USA adapter. I guess, and that's what it's targeting.
Yep. All right. Well, if folks want to pick one up, use our coupon code USBC Fixer. You get 10% off of $4.50. All right.
Do West was saying it beats the dickens out of having to hot glue the whole thing to.
Yeah. Imagine that. It's hot gluing the whole thing.
Some heat shrink.
Yeah. Cool. All right. Very good. That's this week's project. Nice and short, but nice useful. Very useful.
Yes.
Okay. Prototyping onto my thing. So this is like week 3 of sharing the MIDI keyset. So this originally was a USB keyset design. I respun it to be a MIDI controller because I thought it'd be cool. Added 3 potentiometers, rotary encoder, and an OLED display to show some graphical user interface. So these are chalk key switches in here. You might hear some sounds here. So that is just the music software running in the background. This is outputting MIDI notes, all done in CircuitPython code. So the screen we finalized. Me and Liz have been working on this one. I came up with the concept of the user interface, and Liz helped out with coding it. I worked a little bit on the code, getting some of the display I/O labels and graphics going. So the idea is that you have 3 circles at the top, which represent the 3 potentiometers, and then you have 5 kind of rectangle square chiclets at the bottom that represent the notes, the MIDI keys here. And you'll see that the values are on the circles, and there are letters and numbers on the keys. So the keys represent the notes. So we got like C sharp, E3, F sharp, and so on. And we have values up here for the potentiometer. So as I rotate the potentiometer, the value changes to reflect what value it is. So all the way at the bottom is 0. And all the way at the cranked up all the way to 11, it's 127 in MIDI values. So what's cool is that we can use a rotary encoder to change the kind of highlight what's selected. So let's say I want to change the note from C sharp right here. So if we do a short press using the rotary encoder, it'll go into that note edit page. So now we have a little title here that says edit key 1. So that's the key. And you have 3 different values here, 3 different items that you can change from. So you have the MIDI note, you have the velocity of the MIDI note, and the MIDI channel. So if we want to change the MIDI note, all we got to do is do a long press, and then the item will highlight and kind of invert. So now it's selected as white. And as I rotate the rotary encoder, it changes the MIDI note. So what it was like, what, C sharp? So you can actually live play it. So now it's E3, and you can go all the way up to like, I think, E6. You can go all the way down if you want to, like, an octave down. We go to E sharp, E2 sharp, C2 sharp. And you can short press to exit to go back to the main menu. And so that's changing a MIDI note. So what if you want to change one of the potentiometers? So for example, if you wanted to change the potentiometer, we do a short press to go into the edit page of the selected item. You can see here it has CC number, range, and MIDI channel. So the CC number is pretty, self-explanatory. You change the number of the CC that you want. In MIDI world, 1 is like modulation, and I think 2 is like expression pedal or something. So same thing, you long press to change it up, and then you can, when you're in edit mode, you can change it. You can change the value. I'm going to leave it on 1. You can do a long press to kind of exit edit mode, but stay inside the edit page, which is nice. And then let's say we have something where we want to change 2 values inside of 1 item. So in this example, we have range. So the range of the potentiometer can change. So if we do a long press, and now we can rotate to change either the maximum value or the minimum value. So if we want to change the minimum value and trim it, we can do another long press, and you'll see it changes to black. So that means that we are changing that value there. So I can trim it to like 20, 30. And then if we want to exit that, do another long press, and now it's set.
Nice.
And to go back to the main menu, another short press.
Woohoo.
I think this right here, I have it assigned, the middle one, the middle pot, I have it assigned to delay. So and then this one I think is assigned to like an LFO. So yeah, that's a quick demo of our MIDI controller. Pretty fun, simple MIDI controller. We'll have a guide for this. It's probably next week, maybe next week or the week after. Hopefully before CircuitPython Day, which is August 15th. So we're working on documenting it now. Yeah, it's a lot of fun. And I think it's a fun example of CircuitPython MIDI code, especially with the OLED display and doing all the fun editing menu stuff. So that was a lot of fun to work on. Yeah, so if folks have any questions and stuff, we can talk about them. Yep, it's running the Adafruit KB2040 microcontroller, which is inside here. This is a 1.3 OLED display. These are chalk key switches. The enclosure is completely 3D printed. The rotary encoder is just a bare rotary encoder with the switch. It's not the STEMMA QT one because we just didn't really need it. And the potentiometers are just analog potentiometers. It all snap fits with a couple screws here. Yeah, it's kind of fun. So that's that. Still working on the guide. The next thing I want to talk about was the Fruit Jam case. So we have different versions of it. One that's like a single color version that has like a little bit of a engraving of the logo. And then this is like if you have a multi-material printer, you can do multicolors on the logo. So that's cool. So we refined it so that everything's really, really tight. So we have all the ports are here. Audio jack. We have this really nice on and off switch. Let's see if we can hear it. Has a nice click to it. We expose the GPIO header pins up here. Yeah, so I just submitted my order for JLC PCB. We're going to try this in like 4 different colors. We have white SLA resin. We have translucent resin, black resin, and gray resin. So we're going to try all those different colors out. We had a lot of back and forth because like a lot of the walls are kind of thinner than they needed to be. So I thickened everything up and everything's ready and under spec for resin printing. I'll share these files probably later today. I'll try to get these files out for folks. We had a couple team members in Adafruit print it out for us. So shout out to Brent, Anne, and John for printing out and getting some really good feedback on the design. Let's see what else. We've tested everything, so made sure that all the ports, all the cables connect. So STEMMA QT, 3-pin JST, USBs over here. The HDMI is now like really nice and flush. USB-C, and then the SD card here. Yeah, buttons. You got 3 user buttons here.
Oh no, I just realized I did not test the headers.
Yeah, I don't have something to test it with, to be honest. It's a very custom header. I think it's 2 by 16, 2 by something. Yeah, I don't have anything to test it with other than jumper cables, but those should fit fine.
I think I do, like some of the Pi stuff, maybe?
No, the Pi's like 2 by 20,
30,
I think 2
20?
by 20, something like that. Yeah, so I haven't been able to test that yet, but otherwise everything else is good. Nice little grill in the back here. It just opens like that, and there are these like little pegs here that keep the thing in place, so there's no screws needed. The way the switch works is you just fit it in to the little hole here because it is a separate piece that you're printing. So you just fit that through the hole, and then there is a little nubs here that will kind of latch onto it. Yeah, so it can't fall out, which is great.
Yeah, show that because I tried pushing it through, and I was like, "Wait, this is not gonna work." Yeah,
you install it like that, right?
Yeah. Mm-hmm.
And then you make sure it's all, make sure it's lined up with where the position is of the actuator here. It's pretty long, so you're able to grab onto it. So once it's lined up, you just fit it on like that, and then you can kind of see here that those tiny little nubbins kind of fit right over the actuator so that it can't fall out. And you can kind of see it there. I did have to cut that little thing open there, not just so that you can see it, but so that it has the clearance. So that's how that's working. And you're just gonna have to know that like the far right is on and this is off. Yeah, maybe on a V2 I'll add like a little I and an O here. I think there might be room for that. But I did end up thickening this up because when Brent printed it out, it like instantly broke when he tried to get it off the bed of the printer. So I did thicken that up, and because of that, I had to like make the hole bigger and all that stuff. So a lot of little tweaks and changes here, but yeah, hopefully it comes out good from JLC in the different resin parts. And it'll be interesting to see the tolerances if they differ from material to material, because it's not just a color change; it's actually different resin, different printing process. But folks have printers.
Makes it looser, the black. But I've not tried gray, so I'm curious to see the look and the tolerance for the gray.
Yeah, let me unplug this. And Dan Halbert actually had a good like, oh, where's the NeoPixel hole? Like how are the NeoPixels going to show? So I kind of took for granted, like, oh yeah, that's right. There's like a special window here that is thinner, and it has like a light guard that allows the NeoPixels to only shine through the area that we want it to. So here you can see it doing a rainbow and then kind of doing different LED animations. There's a little bit of a light leak here. That's just the way it is because it's all printed in one color, but you still get a nice kind of look here. So I think this is a good way to kind of do a NeoPixel effect where you can still get color to shine through, but you're not having like this gaping hole. And it's nice to actually diffuse the LEDs because they get really bright. And this way you get like a nice kind of hidden magic LED window. And so this is a CircuitPython demo code of the LED animation library in CircuitPython. So it runs through the different rainbow colors. I think this is 0.2 brightness. So you can make this way brighter.
Yeah.
And I think it'll either leak more or just be more vivid. But Anne Barella printed this out in black.
And it
actually looked really good. Yeah, the color actually should look really nice. And because it's only 2 layers thick or 2 layers thin, the color really shined through. You can kind of see the individual pixels through the it's kind of like a transparent black with a little bit of glitter in it, which is cool. So different filaments will obviously give you different LED diffusion. That's why I try to print everything in white first, just to kind of get like how does it diffuse LEDs? Nice. So yeah, these are 5 pixels, and I think when it cycles to the blue one, it's like cycling through each pixel, like 1, 2, 3, 4, 5. So you can kind of see how it looks like if you're just addressing one pixel to light up at a time. So not as sharp as you might like, but at least you get some kind of idea of what it looks like. Yeah, what we'll use the NeoPixels for in whatever project is kind of up to you, but they're on there. And I like the comet effect. That kind of looks really cool. You get some sort of animation there. That's not just like one solid, light bar. So yeah, that's the NeoPixel window. Yeah. Oh yeah, you can see the logo much better there. It's just like one layer. Cool. And then of course this on-off switch works nice. Turn on off. So that's the Fruit Jam case. I'll try to get these files out by the end of the week. And then the last thing, because we're not done yet with more cases, this is the 2025 edition of the Adafruit MagTag. We were tasked to make a 3D printed case that fully encases it. It's about 20 millimeters thick, nice and chunky. But this has a special feature. We haven't done this yet. This has a printed place stand. So there's a little notch here that allows you to use the tip of your finger to pull out this print and place stand. So you have this stand that allows you to kind of have adjustable viewing angles. So this is like as full extended. There's like 170 degrees, whatever that translates to. Or you can kind of lift it up a bit like this and have it more like your traditional like 70 degrees. So that's really cool. Let me see if I can get a good shot of it like that. So that works really nice. You can, there's this tiny little nubbin that allows you to, let's hear it, snaps in and then it stays in, which is nice. And then you can pop it out, click it in again. So that's really nice. And then you have these 4 screws here. You can use the Adafruit magnet standoff. So if you want to still use these, you can still use them. So that's why we have the screws back there. And then we're still working on a good method of getting the on-off switch. So it's pretty similar to the Fruit Jam one, but the problem here is that it's a different switch. So this actually falls right out. So I'm still working on a different way to cap this. I'm thinking that I'll add some extra geometry to the nub here so that it can latch onto some other piece that's built into here, so that when this is in and the top is on, it'll like lock onto the top, because right now it just falls out. So still working on that. But these buttons are separate buttons. So they do work. They're just separately printed, and then you just pop them in. And then we have 2 more buttons on the side here. These have reliefs on them so that you can click it. There's a boot button and a reset button. You got your USB-C port there, which is lined up, and 2 3-pin JST ports, and then our STEMMA QT port, which is the I2C stuff. So yeah, I think it's on. So I'm just doing the CircuitPython slideshow demo code. There it is with the NeoPixels on. And so the lights actually diffuse nicely. And just kind of showing the interface there, the MagTag slideshow. There is a battery. There's a 500 milliamp LiPo battery that fits in there. And let me just take it apart. I think I can just do that. And you can see all the buttons fell out, which is fine for this demo. Oh yeah, I'd have to unscrew it to show you the battery. But yeah, the batteries fits perfectly behind here. You can kind of see the cable there. So that's the battery. And yeah, I unscrew this, but it's gonna take a little bit. But yeah, there's a battery that fits in there. You can use a 500 milliamp LiPo battery, which I think is plenty. And then these little things will be printed separately. And then the reason why it's not just one piece is because like you get better separation when they're printed separately. So there will be a little bit of assembly required here where you have to kind of put these in and then just pop that on.
And JLC doesn't have the flexible stuff yet, huh?
TPU? I don't think so. I mean, it works pretty good with the solid PLA. So let me do a reset. Does that reset? Yeah, that's reset. You see the lights will turn on, maybe not. It looks cool when the lights are fully on. Yeah. There's some deep sleep code in here, I think. So like the lights will shut off automatically. There you go. trying to get light. Come on. Takes a little bit for it to refresh. Here you go, JadaBot.
Yeah, the weather one does it.
Yeah, the weather one does it. Yeah.
Plugged in, yeah.
You got you printed one too for testing. You got the new MagTag, so we're just trying to make sure it all fits. Yeah, I'm excited about this this right here. Although it might be problematic because I've had some print in place issues arise with JLC PCB 3D where they didn't allow it, but PCBWay did, and there's like different tolerances. So I don't know. It's going to be kind of tricky. I might do a separate piece where this clicks into the little hinge. So I might have to do that. I'm still working on this issue with the on-off switch. So there's still work to be done, but I think we're this is a good concept here. We're getting there. Just a lot of little things to look out for. Yeah,
the screen is beautiful. It looks like paper.
It's a really nice crisp screen. It's low power. It's an ESP32. It's got all the expansion ports that you could want. I don't think it has SD card, right? There's no SD card reader. I would have made a hold for it. So, but it is portable and all that. So it's really nice. Got the LEDs built in. Great IoT dev board with the display built into it. We got a question from Tyeth on YouTube. Does the case have any light wells for the top RGB LEDs? Not really. I might play around with some more diffusion, but like, I think that's as good as it's going to get. Let me see if I can restart it again. I think I had some demo code that just had the lights on, but I've since changed it out. Yeah, it's hard to get the light in there. Yeah, you can kind of see the individual lights. Like I wish there were more evenly diffused, but I really can't do much about it because it's already like this much off from the PCB. I don't want to make it any thicker, and if I make it thinner, you'll even get less diffusion on the lights. But it is cool that this bezel is a pretty big bezel. It's a 45-degree bezel here, and it lights up kind of nice. Yeah, because if you take a look here, when I open it, you see the lights actually, the silk screen kind of gives you an idea of what the lights are doing. So there are these side lit pixels, and there's only 4 of them. And you know what? I just realized that there is an ambient light sensor there.
Oh, crap.
I don't have a hole for it. Yeah, that bezel glow is cool. Thank you, Tyeth. Yeah. I forgot to make a hole for the I think it's an ambient sensor. So the idea is that when it gets dark, it'll turn the lights on or something. Yeah, I need to add poke a little hole in the middle there, so that when you put your finger over it, or it senses that there's a shadow or something, or it just senses that the ambient light is dark. You know, it'll do something, and then I need to block it so that the neopixels don't interfere with it. You know? So there's still a lot of work to do, I think, but I'm digging this print and play stand. Like this is the first thing I tackled, and it took a lot of iterations to get this tolerance thing to work out. Because you can notice that there's I needed to add this like overhang ledge here to prevent the thing from folding in on itself. So that was kind of a new thing. And then getting the size for this right. And then there are these little nubbins. You can just barely make them out here, but these one of them allows your fingernail to kind of grip it, but then the second nub is what actually goes underneath this tiny little bit to kind of keep it clicked in spot there. Yeah, so there's a lot of work on that one. But yeah, I think this will be a cool thing to apply on other cases that could use a built-in stand. Yeah. And this was all Lamar's idea. She was like, you should do a built-in stand. It's like, oh yeah, we should try that. I haven't really done that yet. So that's it. That is the MagTag case. And segue to CircuitPython Day. It's going to be August 15th. That is a Friday. That is is it 2 weeks from now, I think?
Yes.
Yeah, not this week, but what is next week? Let me double check. Well, they had a calendar on my fruit jam. Yeah, It actually is next week.
Oh crap!
This Friday is the 8th,
man.
and next Friday is the 15th. So I really got to get this MIDI project out the door before then. A lot of white going on here, which is nice. White colored PLA
Gives it that retro look.
Yeah, I'm liking normally I'd print everything in black, but like I don't know, I'm kind of liking this white filament from Polymaker, or what's it called, Panachroma. That's their new brand. Yeah. All right, prototyping all the things. So if you want to pick up a Fruit Jam when they're in stock, or a MagTag when they're in stock, well, our coupon code's only good for today, but you know what I mean. USBC fixers is coupon code. Got to work on my delivery, you know. All right, let me check in on Discord. Find out, catch up with the. Okay, thank you, Squid.jpg says looks to design reminds him of something from Severance. Didn't realize there's a single color version. Yep. Of button flaps. Yep, thank you. 2x16 is the GPIO header for the Fruit Jam. Thank you, Squid.jpg.
Might
Yeah,
have.
I'm gonna try these transparency. Yeah. Okay. Yep. This a compatible black plate might be good. Okay. LG Windows Select. Yep. Thank you. Raspberry Pi monitor. Yep. Like my magnets, says Dubuster. Yep. Oh, this is great. Oh, I'm gonna try this out. This is a ISS tracker from Squid.jpg, so I will check that out. Thank you so much. Yeah, I'm looking for more IoT projects to load on here and test out, so that's perfect. Sweet. And sign up to get notified when the MagTag is back in stock by just searching for MagTag. Thank you, everybody who purchased batch 1. Let us know how it goes. This is, of course, a new chipset. It's the SSD 1680. And it's got CircuitPython support. It's got grayscaling and all that good stuff that you're familiar with. I think the guide got updated to kind of reference some stuff. Yep, the display has been updated. The old one was discontinued. It has a new chipset. And it has CircuitPython, Python, and Arduino support. So check out the Learn Guide. We have a lot of Learn Guides too. So you can click on See All Learn Guides and see all the different Learn Guides that folks have worked on. Some of them, the APIs change, like the Twitter one, like this is no longer Twitter, right? This was a good one. I got this one loaded too. The weekly show times. It's a nice one.
Oh yeah.
Like the display one is pretty classic. That's overall always useful to have all the weather forecasting on it, which is good. There's some Google spreadsheets support, which is cool.
Oh,
tides. You can get the tides. Google Graveyard. That was funny. I wonder if the Google Graveyard API has been graveyarded or whatever. SpaceX launch, countdowns, lots of stuff. Yeah, it's a great little.
Have that one on my shelf.
Oh yeah.
An update. I think it's the API change, so it stopped.
Probably. Yeah, this was from 2020, so 5 years ago. But the MagTag is back. It's been on the back burner for a while now. Ooh, a terminal. Tyeth is distracted trying to turn the MagTag into a terminal e-ink screen. Local server ran and at the place flashed. At least I don't know what to do. Cool. Yeah. That's a. Have you heard of the terminal e-ink screen? It's like this big iPad that's like a,
yeah.
It's kind of making rounds in the tech space. Yeah, very cool. Ours is a little tiny one. I think Lamar wants to make a big one. Who knows? We'll see. All right, that is all the prototypey things.
Awesome.
Are we doing? Well, let's talk about CircuitPython Day real quick.
Oh yeah.
August 15th, next Friday.
Woo.
We have a blog post here. Let's bring it up, where you can ask questions for Dan and Scott, who are the core devs on CircuitPython. So there's a link here. So you can add a question here. You know, sign in to your Google thing. And you can tag stuff on social media, and Anne will pull it in, and we'll talk about it on CircuitPython Day. We're going to do our usual stream starting off at 11 a.m. on Friday. So that week we won't have it on Wednesday. So that'll be nice. We're going to put the show off on, not on Wednesdays, on Friday for next week on the 15th. So there's your programming note. So yeah, it's a feature blog post, so you can check it out. So yeah, CircuitPython Day, special live streams coming up. We're all trying to get our schedule lined up, but we'll have links and stuff more as we get closer to it. It's really almost here, so we got to really get our stuff together.
Remember a month ago, we were like, it'll be here before we know it.
Oh, I know. And then here it is. We're like, oh no, it actually is next Friday. So that means next week's show is actually on Friday. So
nice.
There we go. All right.
Yay.
Yeah. Exciting.
Things always happen on Wednesday that I can't do because it's show day.
Right. Now you can have your Wednesday.
Yeah.
Yeah. I'm going to be heads down on this guide. So my deadline is Friday to get this guide out. So that's good for me because I have like one photo of just parts, and I was like, I got to start soldering stuff and showing that off. All right. Pedro has a time lapse. Every week we do a time lapse. Find something from the community, print it out. This week, it's a multicolored fidget spinning Pokemon.
Yeah, this is Ferroseed for this week's community make. Timelapse Tuesday. This is a little fidget toy of this Pokemon that I've never seen and never heard of.
I've never heard of either.
No. The kids didn't either.
Oh, yeah?
Super
well,
cool.
There's like a lot of Pokemon.
Oh, there's like thousands of Pokemon.
Pokemon.
So this is a really cool one, multicolor, very nice design. And it is designed as a little fidget. So all the sections rotate around a central little rod. And let's see if I can take this off to show it disassembled. There we go. As you can see here, excellent job on the designer doing all of the separate pieces, allowing the center rod to add as a catch for all of the purged material so that does not get wasted.
Oh, that's all brilliant.
Cool. Yeah, it's a really cool way to save on the purge. Just have a flush item that's not going to be visible. So nice way to do that. And the pieces just get inserted here. You can see here they have the little connector nub that is actually going across this. What shape this is? Like a little star. So it has like some catch when you do your rotation. And then just press fits in. Nice, good tolerance to connect that together. So excellent use of these parts that snap fit like that. Like that. And super cool. Nice little fidget toy. The spikes are super sharp, so you do have to sand those down, unfortunately. So I gotta do that before I hand this over to the kids. Hopefully they don't throw it at each other.
Oh boy. Yeah,
but nice, nice separation of the colors, having that blue, and we're using I think it's the Galaxy Sparkly Protopasta one. Or no, the Everyone filament. And yeah, nice. Simple. Cool. Not so simple. It takes I think 7.5 hours to print because of all the color changes. But nonetheless, super cool little print.
Yeah.
A Ferro. What is it? Ferroseed Pokemon.
Yeah.
Looks like it'd be a Pokey egg itself.
Huh. It was posted up by Bruddz on Maker World, and it's a free download. So you got your 3MF. You can choose all the different colors you want.
Yeah, it loads up all nice.
Some print instructions. There is a couple support material pieces.
I think the eyes, and those came right off, like stayed behind on the bed. So the settings are all set up for you on the 3MF, and
Nice.
excellent print.
Very cool.
Apart from the spiky spikes.
Yeah, they look a little rounded off there.
I mean, they do here too, but you can definitely feel the pokiness.
The pokiness. They have to be pokey. It's a Pokemon. Pokemon. Did you add glue to the bottom hole?
No, I did not.
Okay. All right. Optional.
Yep, the tolerances were tight enough.
All right. I'll drop in the link there. A little bit of a discussion. Oh, I see. Okay. Squid might update the CircuitPython 10, the code for CircuitPython 10. Yeah.
Nice. Yeah, I noticed for the weather one, something needs to be updated. The code did not come through, but in the guide, you can just copy the code over.
Yeah. Okay. Yeah, I noticed a couple things too, like with this the events, like some of the anchor points for text items like kind of change, so I had to update that. Yeah, we're still going through and checking all the different guides and seeing what works and what doesn't work, so we're working through that. Got a comment here from Joe on Twitch saying, thanks guys, I enjoy your 3D prints and your tutorials. Currently working on your Halo sword on an X1 carbon. Having a couple of issues here, but for the most part the prints came out pretty clean. That is good to hear, because we have yet to print our older drops.
That was on the cruelty. So if it was loose or tight, that's why. It was designed for different salt tolerances.
Yeah, but there should be a step file out there, so if you want to make changes, or you can change up the STL.
Yeah.
Cool. All right. I think that's gonna do it for the show.
I believe that is it.
Yeah. So as I close down the show, I'm trying to. So this week, tentatively, Lamar and Phil will be hosting Show and Tell, but things can change as they're winding down for paternity and maternity leave. So if everything goes to plan, normally our Show and Tell starts at 7:30 p.m. Eastern Time on a Wednesday, right here on all the channels. And you can get an invite to the StreamYard a little bit before 7:30 if everything goes to plan. Same thing with Ask an Engineer. Normally it starts at 8 p.m. Eastern Time, but things are subject to change. Just rapid, fast motion. How Lamar and PT are trying to get everything together for the shows. Yeah.
I think finally next year they're just going to switch it to like 3 p.m. during the day, which will
that's all tentative. We don't know. Things can change. Yeah. We might change the date. We might not. I don't know. But JP's workshop is tomorrow on Thursday at 4 p.m. Eastern Time. We got Foamy Guy on Fridays at 5 p.m. Eastern Time or 2 p.m. Pacific. And then Mondays, I think this week coming up, it is a CircuitPython weekly meeting. It's been bi-weekly because it's summer and it's kind of changed a little bit. Tuesdays is JP's product pick of the week. Starts at 4 p.m. Eastern Time every Tuesday. You get up to 50% off select items. Yeah. And then next week, we will be on Friday for CircuitPython Day.
What was the catchline? The snakiest day of the year.
Day of the year. Yeah. Yeah. It's normally on Friday. It's a holiday for us. So, yeah. All right. I don't know what else. I think that's it.
That is it.
I got to get back to this guiding here. I think, I don't know. I'll see if I come on show and tell. I might share the Fruit Jam case. I might run out of time, but we'll see. Yeah. Well, again, PT and Lamar hopefully are going to host. If not, maybe we'll get a standby guest special guests. You never know. So we'll see. Thanks everybody so much for watching. Again, if you want to pick up anything in the Adafruit shop, please use our coupon code USBC Fixer and get 10% off your order. We appreciate everybody putting in their orders and using our coupon code. Helps keep the lights on. All right, folks. We'll see you next week on CircuitPython Day, August 15th, Friday, next week. Put it on your calendar. Put it on your MagTag. Put it on your terminal. Thank you, everybody, so much for watching us live and folks watching on the archive. We'll see you next week on Friday. But until then, remember to make a great day. One day we'll get that in sync. Bye, everybody.
See you next week.